Hello everyone, welcome back. So today I'm here to discuss about the analyze modulation techniques in digital TV broadcasting, so which comes under the digital communication. So let us start with an introduction to it. So this digital TV broadcasting has revolutionized the way we receive the television signals. So it offers improved pictures and sound quality compared to analog broadcasting. Understanding modulation techniques is essential for optimizing the transmission's efficiency. So the next is the importance of this modulation. The modulation is a process of varying the carrier signal to transmit the information. So it enables the efficient transmission of data over various media. Effective modulation techniques can enhance signal robustness and minimize the interference. So the next is the type of modulation techniques. So there are several modulation techniques used in digital TV broadcasting. So each technique has unique characteristics that choose different transmission conditions. So common type include QAM and OFDM and PSK. So let's move on to the quadrature amplitude modulation, that is QAM. So it consists both amplitude and phase modulation to transmit the data. So it allows for the transmission of multiple bits per symbol, increasing the data rate. So higher order QAM can achieve better spectral efficiency at the cost of robustness. So the next is orthogonal frequency division multiplexing, or FDM. So it is a multi-carrier modulation techniques that involves the signal into multiple sub-signals. So it is highly resistant to multipath interference and is used in DVB-T and DVB-T2. So OFDM can efficiently utilize bandwidth, making it ideal for high data rate applications. So let's move on to the phase shift keying, PSK. So PSK is a modulation technique that encodes data by varying the phase of the carrier wave. So it is robust against the noise and commonly used in satellite and terrestrial broadcasting. So variation of PSK such as QPSK can transmit multiple bits per symbol. So the next is the comparison between QAM and OFDM. So while QAM is effective for point-to-point communication, whereas the OFDM excels in multiple environment. So QAM has higher data rates but more susceptible to noise and interference. OFDM is resilience makes it suitable for urban broadcasting scenarios. So the next is the error correction techniques. Error correction is vital in digital TV broadcasting to maintain signal integrity. So techniques such as Reed, Solomon and Turbo Coach are commonly used. So these methods help recover lost data and improve overall transmission reliability. So let's move on to the channel allocation and bandwidth. So this efficient channel allocation is crucial for maximizing the use of available bandwidth. So modulation technique must be adapted based on the allocated frequency spectrums. So proper bandwidth management ensures minimal interference and optimal signal quality. So the impact of signal interference. So interference can significantly degrade the quality of TV broadcasters. So the modulation techniques are designed to mitigate the effects of the various types of interference. So robust techniques can maintain the signal therapy integrity even in challenging environments. So the next will be adapting to the transmission conditions. So the digital TV broadcasting requires adaptive modulation to respond in various conditions. So techniques like adaptive modulation and coding that is AMC, can optimize performance in real time. So this adaptability ensures quality viewing experiences regardless the signal fluctuations. So the next is future trends in modulation techniques. The evolution of digital broadcasting is leading a new modulation innovation. So techniques such as 256 QAM and advanced OFDM variations are being explored. So future trends may involve integration with 5G technology for enhanced broadcasting. So the case study for DVB T2. DVB T2 employs advanced modulation technique for terrestrial broadcasting. It uses 256 QAM and OFDM to achieve high data rates and improved coverage. So this technology supports multiple services and enhance viewer experience. So the next will be broadcasting. So global standards in digital TV broadcasting. Various countries have adapted different standards to digital TV broadcasting. So standards like ATSC, DVB, and ISDB define the modulation technique used. So understanding this standard is essential for compatibility and interoperability. Let's move on to the modulation and reception equipment. Success of modulation technique relies on compatibility reception equipment. So set-top boxes and integrated tuners must effectively decode modulated signals. Advances in technology continue to enhance the performance of these devices. So let's move on to the role of satellite broadcasting. Satellite broadcasting uses unique modulation technique due to its transmission environment. Techniques like DVB-S2 utilize QPSK and 8PSK for efficient bandwidth use. Satellite broadcasting provides coverage to remote and rural area effectively. So the role of regulatory bodies. The regulatory bodies set standards for modulation techniques in broadcasting. They ensure compliance with technical specifications and prevent interferences. So their role in crucial is crucial for maintaining the fair and efficient broadcasting patients practices. So the challenges in digital broadcasting. Despite advancements, digital broadcasting faces several challenges. So it uses such as signal degradation, interference, and equipment compatibility persist. So ongoing research aims to overcome these obstacles and enhance broadcasting quality. So at last, the conclusion. Modulation techniques are fundamental to success in digital TV broadcasting. So continuous environment improvement and adaptations are necessary to meet the evolving demands. A comprehensive understanding for this techniques is essential for industry professionals. Thank you.